Okay, so simple phenomenon involving an ellipse, F1 and F2 are its foci, and a point O that I designate as a fixed point, and a point P sub t or P of t on its boundary that I'm going to slide here over a region. Okay, now when I slide it over this small region of the boundary here, subset of the boundary, I can always draw a circle centered on O passing through P of t, right? So this is the circle here that is centered on O and passing through P of t, the circle over here. Now this circle over a small arc here of the ellipse is going to cross said ellipse in three other points, which I'm labeling here A, B, and C. Now let's consider this quadrilateral P+A+B+C, and I'm going to draw its three centroids, C sub 0, which is the centroid, the vertex centroid, C sub 1, which is the perimeter centroid, and C sub 2, which is the area centroid. Now one interesting phenomenon that we've observed here is that as I slide P sub t on the boundary, while C sub 1 and C sub 2 move, C sub 0, the simple average of the four vertices of this family of quadrilaterals, seems to remain stationary. We don't know why that is. Of course, if I move O around the center of the fixed center of the circles, the fixed position of C sub 0 will change, okay? But over the quadrilateral family, it remains stationary. Now, if P of t exits a certain region, you can see here that at some point the circle will no longer intersect the ellipse, and you're going to get some complex values for B and C. Let's look at that. So right here, B and C disappear, right? So now I have a quadrilateral with two real vertices and two other vertices that are in the complex plane. Now the question is their average, C sub 0, going to remain stationary? I believe it will. We would have to work out the algebra here. But you can see that C1, the perimeter centroid, and C2 do not remain stationary. Now if I move O around, I will place C0 elsewhere, but regardless of the position of O, C0 stays stationary. Okay, that's all I have. See you on the next video.